Hello, everyone. We are going to continue discussing Lewis structures by discussing how we can use the octet rule to predict the, the structure of a little bit more complicated molecules. Please make sure you have watched the initial video on Lewis structures before watching this one because you want to understand what a Lewis structure is before we go about going through a more systematic process to determine Lewis structures for um, slightly more complicated molecules than the ones that we're showing here. This process works for molecular ions as well. So basically polyatomic ions can be determined in this way. So the first step is to determine the total number of valence electrons. Um, if so, basically you're doing the Lewis dot Lewis dot symbols for this that we had discussed earlier. So you would basically could do that to determine the number of valence electrons. If you have a charged species, then we have to adjust that. So if you have a cation, subtract 1 electron for each positive charge, and then for anions, add an electron for each negative charge. So you can add or subtract electrons if you have charged things and to your tally of the number of valence electrons. So I want to, as we're going through this, what I want to do is I want to jump from the step we're doing to an example. So some examples down here for these 4 things. You'll notice 2 of them are charged and 2 of them are not. So here we're looking at SiH4. So silicon we could see has 4 valence electrons. Hydrogen has 1 valence electron. We have 4 of them, so we have 4 plus 4 is 8 valence electrons. If you're not sure why silicon has 4 and why hydrogen has 1 valence electron, please pause this video, go back and watch the video for 7.3a on the Lewis symbols to make sure you understand that before going forward, because that is important to understand with what we're doing here. Here we have something with a negative ion. So what we would do here is we would say, okay, carbon has 4, hydrogen has 1, oxygen has 6. We have 2 oxygens, so times 2 is 12. Again, make sure you know how we're getting these numbers. So go back and watch if you need to. And then with a negative charge, we have 1 extra electron, so we end up with 18. I'll let you look at the next 2 if you need to. But make sure you know where these numbers are coming from. If you don't know where they're coming from, you will not be able to get the correct Lewis structures for these. So the next step says draw a skeleton structure of the molecule or ion, arranging the atoms around a central atom. And what I would suggest here in terms of deciding, well, what is the central atom? If you look at the formula for the molecule, whichever atom comes first in the formula is the central atom. And the exception to that is hydrogen. So hydrogen is never the central atom. So if it starts with hydrogen, don't put hydrogen in the center. If it starts with anything else, put that element in the center. And then we connect each of the other atoms to the central atom with a single bond. For now, we're assuming we have exactly one central atom. That is not always the case, but those other even more complicated molecules are subject for a later course. So for now, we'll assume 1 central atom. So let's continue with our example. So here we're showing that. So for the SiH4, the Si goes in the center and each of the hydrogens is connected to it. Okay, so you'll notice that there is one thing connected to everything else, is what we're showing here. And then likewise for these others. In this case, it doesn't matter which one we call central because there's only two of them. Here you'll notice we have more than one type of atom connected to the central atom, so that can happen. But in each case, we have one thing in the middle and everything else connected to it. We don't have like a long string of things connected away from this whatever we did first. Everything is connected to one thing in the middle. And then the third one, distribute the remaining electrons as lone pairs on the terminal atoms, completing an octet around each atom. So let's talk about that. So when we say terminal atom, what we mean is any atom that is not the central atom. Exception there is hydrogen. Of course, hydrogen only needs the one bond to satisfy the octet rule for it. So let's look at this step down here. So we're showing our examples. So this one didn't need anything else. It was kind of already done. For the next one, we have one hydrogen, so we don't have to add to that. I'm going to make it so we can see both the ones up here and the ones down here. And then we put on the oxygen, we already have two from the bond to the central atom. And so we put 4, 6, 8. Same thing here, already 2, 4, 6, 8. So we're adding electrons so that we have an octet on each of the outside ones. This one is a little bit different in that we kind of run out of electrons. So when I said we're adding to the terminals, that's based on the number of electrons we started with. So for this one, we have 18 electrons. So let's make sure we didn't go over that number when we did this. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18. So we used up the 18 electrons, starting with the terminal atoms first. On this one, we only have 10 electrons. Okay, so when we do this one, we have the bond, so that's 2, and then we have 4, 6, 8, 10. In this case, we couldn't get 8 electrons on each of the atoms. We'll be exploring what to do with that here in a minute. You'll notice that this one also did not have 8 on each of the atoms. And then here for this one, we have 20 electrons. So here we have 2, 4, 6, 8, 10, 12, 14, 16. So we've the terminal atoms are both have their 8 electrons, but we haven't used up all of the electrons because we have 20 altogether. So some of these we can tell are not quite done yet. So let's continue with the next step. So after we've done that, any remaining electrons go on the central atom. So we only have one of these that didn't use up all of the electrons. So here we used them all up, here we used them all up, here we used them all up. Only this one has leftover electrons. So we're showing what we get here. So we had 16 electrons. So we have 20 altogether. That means we have 4 left. So we put 2 here and 2 here. So that gets us to our expected number up here of 20 valence electrons. Okay, so as we're doing steps 3 and 4, we're basically counting electrons, and we make sure we have whatever we counted at the start in step 1, that we're using exactly that many electrons by the time we are done with step 4. If we're not doing that, we're not drawing the correct Lewis structure. Okay, in step 5, we do some rearranging of electrons. Now, why would we do that? Let's actually go back and read step 5 up here. So step 5 says, rearrange the electrons of the outer atoms to make multiple bonds with a central atom in order to obtain octets wherever possible. Okay, so step 5 we are only doing if we don't have octets somewhere. So let's look at the structures we have. So for the first one, we kind of ended way back here. It already has an octet on the silicon. This one does not. We only have 6 on the carbon. Neither one of these have an octet. And this one, when we did this step 4, we got to the octet. Okay, so these two we are going to have to look at a little bit more. Okay, so what we're going to do here is we're going to take electrons from an outer atom and connect them to the central atom. So we're moving the location of those electrons to somewhere else in the molecule. And when we do that, it allows us to count those electrons as belonging to both the central atom and the terminal atom. So we're showing that here. So the carbon now has 2, 4, 6, 8. So it is satisfying the octet rule. The oxygen still gets to count those electrons in the double bond, the same as if they were part of the lone pair. Okay, so that will satisfy the octet rule. And then likewise for the next one, here we can move some electrons from one of the outer atoms to form a double bond. And when we do that, it gives us 2, 4, 6, 8 on one of them, but not on the other one. So what we then do is we then take these from the other one and bring them over. So then we have 2, 4, 6, 8 on the nitrogen, 2, 4, 6, 8 on the oxygen. So that is what we need to do to satisfy the octet rule. And then nothing on the last one. So we've gone through a couple of examples here already. I would highly recommend going through this example 7.4 and do a few more examples of writing Lewis structures. Let me go back to our set of guidelines. So when you're drawing Lewis structures, you always want to try to go through these 5 steps to make sure that you have the correct Lewis structure. And the Lewis structure is correct if you have the correct number of valence electrons. So what you counted in step 1 is the same as your final arrangement. And also that every atom in the molecule has the 8 electrons that it needs for the octet rule. So please get some practice on this before moving forward.